Almost one. Okay, so we are recording, we are live. We are here. Are you guys nervous about the test? Do you want me to only go over the test? Okay. Let me just go over the test. Okay, so what should you do to prepare for this test? What should you study? Anyone? Quizzes. The quizzes are the word is the quizzes. So let me go over every quiz right now. We have 4 quizzes. I'm going to go over them in a different sort of way. Instead of looking at what you missed, I'm just going to talk about the quizzes and how they're going to be on the test. So let's start with Mod 1. I have a different way of getting to the quizzes. Hold on. This is the wrong class. Hold on. Okay, so I'm looking at quiz 1. Just for some reason not here. Okay, quiz 1, MC. Okay, so let me talk to you about this test. The test will have vocabulary. There will be 3 questions on vocabulary. You will say them out loud. There'll be instructions that will say these out loud. You're going to be graded on how you say them out loud, and you're also going to be graded on how quickly you answer. So you want to answer them quickly, correctly the first time. The first question will be something easy, like what is math or what is calculus? Okay, if you get nervous and you blow it, hem and haw a little bit, but the longer you hem and haw, is like push it off, and I know it has something to do with this. The longer you take, the more points you lose. Okay, this exam style is called interview style. So it's like you're taking an interview. I want to know if you know them. These are short questions. They require no work, but they say a lot. If you know what math is, if you know what calculus is, that means a lot to me. Because most people who teach calculus don't know what it is. So if you know it, good for you. You impress me. Okay? So there are questions here. And by the way, they're sorted on the test in a sort of difficulty. Like the first one is easy. The second one is less easy. The third one is harder. So in this group here, these are all really pretty easy. I'll call them level 1 questions. What is college? What is math? What is calculus? What is pre-calculus? Those are all very straightforward ones. How do we represent functions and the average rate of change? That might be a little bit more because they have multiple parts. And yeah. What is the average rate of change? That's a little more complicated. If it's not a 1 or 2 word answer, it's a little more complicated. Okay? The instructions will also say that there'll be a spot for you to write the answer, but you can't write the answer before you say it. If you write the answer and you're not saying it first, then you're dawdling as far as I'm concerned, because I'm sitting there watching you and I'm
excuse me.
Yes.
Can you just see my message I sent you on Zoom, please?
I cannot. Oh, sorry to hear that.
I said, can you just check my message I sent you on Zoom, please?
I got it. Okay. There we go. All right. So listen as best you can, because this is good advice for the test. It'll make you feel better. Anyway, you'll have a slot to put the answers in, but the answers are just for you, for your reference. I'm not grading them. Okay, so if you write the right answer down, but you say the wrong answer, I grade you on the wrong answer, or vice versa. I'm not, there's no spelling mistakes or anything. You just write what you think you said. That's where you have some record of it, because I'm not producing any videos. So you could write down what you think you said. Okay, any questions on that? The next group. These are also things that you have to say. So these were the questions, all the limits on all the quizzes. Okay, and you see like the second one right here had a plus in it. Remember, that means approaches from the right. And there's a minus here, so that approaches from the left. Okay, so you have to be able to say these things. And again, it's going to be say this. And it's going to be the same as the first one. You're just going to read it. So you're going to read it out loud, what you think you said. And then if you want to write down what you said, there'll be a little spot for you to write it down. But you're not graded on what you said. And again, if you change your mind later on and you think you're going to have words that I won't be hearing, I'm only listening to the first part of the thing. So even if you think you're going to get more points because you correct it, you probably lose points for not getting it out right away. So try to get it out as quickly and correctly as possible. Okay? Again, you're trying to impress me that you know how to read these things. These are not hard. On a math test, what I'm asking you to do here is not what you normally say on a math test. But you need to be able to do these things. So your future relies on you being able to know how to say these things. Otherwise, it's just different than it
How
used to.
many?
Yes, Acacia?
Sorry.
What?
How
mean-
many will there be? Like the ones to say.
So we're three save. I'm watching the beginning of the first 6 questions. So the first 6 questions are all going to be say out loud of vocabulary, and then there's going to be 3 of these. One of them will be a limit, one of them will be a derivative, and one of them will probably be a higher order derivative. Okay, with other things, with hyperbolics and stuff, or transcendentals. So anyway, that's what you'll see. This limit would be maybe one of them. Okay. Did that answer your question, Acacia? Okay. So the
Yes,
the next 3 questions you'll see are not multiple choice. They're choose all that apply. Do you know what the difference is? So there'll be a list of things and you have to pick all that apply. And they're not that easy because you have to, on that list will be things like power rule, chain rule, quotient rule, or whatever. And you'll have to decide how many of those things were done. This is the reading part of the test where you have to read what you see and pick what's happening. So if you look at this, and by the way, I'm not going to ask you any of these algebra ones. I don't care about algebra, no algebra, no algebra. I don't even care to use algebra to find the limit, but here's one where you use the table to find, so use Desmos in a table to find the limit. That's fine. This is an algebra one, I don't care about it. This one is an arbitrary change. That I care about. You'll see this a lot. This formula is not on the formula sheet either, so you need to know it. When you see it, you need to, it's just the slope formula. Okay? All right. So for those questions, you don't have a worksheet, you don't do any work, you're just reading and you're trying to figure it out. Okay? That's multiple choice. There's nothing you have to say. There's nothing you have to do. The next group, so that's 3 questions, and then 3 more questions. This group here, I think there's 4 questions on this one. So it was only supposed to be 3, but I think there's 4. Okay. These are the ones where you have to solve something. For these problems, it will say very clearly that you are to produce a Desmos worksheet when you're done. You have to do everything. You have to show your work. There's no way you can do these problems without showing work. You can't guess at the answer. So you have to show the work. And then at the end, the last question, you'll attach your Desmos worksheets to them. Okay, that's just to buy you time, because when you're taking the test, you don't want to have worksheets. What'll happen is you have a bunch of worksheet things on the top and you'll just copy them down one at a time into the problem. And we'll talk about that in a little bit, but these are calculations. So these are arbitrated chains. So for these So there's, on quiz one, there were two types of questions you could have been asked. Could have been asked an average rate of change question. Okay, or you could have been asked one of these continuity questions with the tax rates. All right. So if you're doing the average rate of change thing and you're doing it on Desmos, there will be a, by the way, this didn't have it, but your test will have a link right there to Desmos, so you can use your own, use its own thing. But there's the formula for average rate of change. Let me just, oops, sorry. Where was I? Here. Let me just copy this down. So this is the formula to, so I go to the Desmos and I plug the formula in and I make sure that it looks the same. And then I use this, I just say F of this, F of that, and I give an F defined in more than one place here to find out. Hold on. Let's get rid of it here. Yeah. So if I have the average rate of change formula and I put the function in, there's the answer minus S6. If they between 3 and 6, then you put in 6 and 3. Here, let me just show you something. I think sometimes if you have something like A1, B1, another class asked me this. If you have a formula like that, it says add sliders. If you hit all, it'll create A1 and B1 for you. So if you want to go between 3 and 6, you can just type in 3 and 6, and there's the answer, minus 144. Okay? You have to show something. But I will, okay, so the other thing is this is going to be recorded on Honor Lock. So it will see all the stuff you do. If I want to give you partial credit because you missed it, I will look at the video. If you've attached the, if you went in and you did this thing right here where you hit the share and you copy that and you paste it into the last question. So leave that link there and copy and paste it into the last question when the last question comes up. Then you can point to it later, but you can't, I'm only going to give you credit if I see it on the video. And the only reason I look at those Desmos things is if I can't see it on the video, if it's unclear. Then I'll look at your thing. And actually, I won't. You'll tell me to look at it. You'll have it. The only way you can argue with me about anything you had and you want more points on it is if I can see it on the video enough to know that the Desmos you sent me is correct. Okay, you can't change the Desmos. It has to be attached to the last question. You have to do it during the test. Okay, so there's no mailing anything to afterwards. But I'll just show you if I paste it. Control paste. Where did that go? Oh, that was bad. Never mind. I did. All right. How about this one? Do you know how to do these problems? The tax problems. This one also, you're going to have to do this on Desmos. You can't do this in your head. Even if you think you know the answer, you have to write down Desmos. So these have to be continuous. That means if I plug in 19,600 into both of these equations, they have to be the same. That's what that's what continuity means. So if I plug 19,600 into the first part, 19,600 times 12. 19,600 times 12%, do it this way, 0.12. I get 2352. If I plug it into the other side of the equation, this guy right here, I can't copy it, B plus 11%. So it says B plus 11% of X minus 19,600. But it's saying plug in 19,600. If I plug 19,600 into here, see, that's 0. So that 11% doesn't mean anything. That is just 0. So for these to be equal, what does B have to be?
It should be 2,352.
That's it, 2,352. Now they'll be the same. Okay. So If all you're doing is 12% of 19,600, then that's all you have to put into Desmos, but you have to put it into Desmos. Do not use a calculator. Do not try to do it in your head. Okay? Any questions on that? All right. Last block. Okay, so these, find the average rate of change between the 5th and the 15th. Okay, so let me just, actually, I'll do the last one. Okay, so they give you a Desmos length. So I want between 1 and 20. So I click on this. And I want between 1 and 20. So I'm going to go here. I hit all, and then I can hit 1 and 20. There we go. The formula is already in there for us. How nice is that? The reason why it's already in there for you is because I don't need, that's not what I'm testing you for. Once you have the average rate of change and you know what the answer is, you're going to have to say these answers. You're going to have to present them. So these questions at the end, these are the last 3 questions that I also will be grading. And the way I grade the last 3 questions is I go to the end of your video and I rewind until I hear the last thing you say. So you can muddle through this all you like. You can spend as much time. I don't care how much time you spend trying to find the answer. And I don't care if you say it 5 or 6 times wrong. The last time you enter it had better be your final answer. Okay? Because that's the one I'm grading. And the way I would say this is if it says to respond as if you were the writer, okay, you would have to say something like this. You would have to say f of 20, well, you have to say the quantity f of 20 minus the quantity f of 1 and quantity divided by the quantity 20 minus 1 and quantity equals 49, and then you have to say the units. What are the units? Miles per hour. So you have to say equals 49 miles per hour. That's what you'd have to say if it asks you to present this as the writer. If they say to present it as a speaker, what do you have to say? How do they all start? How did every one of our who was a speaker here? We were a speaker. What did it always start with? It began with the letter A.
The average rate of change.
No. Said something else first. Remember this? Yes, has to start with that. According to this is not sign regression. This is a what? Quartic regression. Okay, what?
The average rate of change between the 1st and the 20th hour is 49 miles per hour.
Yes. Yeah.
Professor,
Yes. Education.
can you, after you're done, can you repeat the writer section, please?
Can I what?
Wait, line 8, I don't remember the way you said it.
Oh, I said, so let me just put parentheses in. I said the quantity f of 20 minus f of 1 and quantity divided by the quantity 20 minus 1 and quantity equals 49 miles per hour. Okay, you have to say the math, not the word, not what it means. When you're the speaker, you have to say what it means and not the math. Got it?
Okay, yeah.
And who's asking me this? If you need to write it down, you have this Desmos, you can write it in a Desmos. You can't always write it in the question itself. Sometimes the question just has a slot. So let me just make this clear to you so you know. The test has slots for you to put answers in, but sometimes I can't get what I want because this is Blackboard version 1.0 or something. So it gives you a slot, but it has to be a very specific slot. It can only be numbers, or it can be letters, or it can be short answers or whatever, but I can't get mixed numbers and letters. So, well, I can mix numbers and letters. I can't do it as a formula. So your questions might be formulas. In other words, everybody gets different numbers. There just generates the same question, but with different numbers. And then the answer is only going to be able to be numbers. So you're going to have, if you need to write something down, write it in the Desmos, but you're going to say it out loud. And you're going to save this Desmos anyway. So it'll be a way to attach your answers if you want. Okay. Did that answer your question? Anyone who didn't ask it, sorry. Okay. I know this question is going to be there. I know average rate of change is one of the last three questions. In fact, I'm pretty sure it's the third to last question. Okay. So that was quiz one. Do you want to, any questions on quiz one though? You have an idea of what I might ask you on quiz one? I'm really kind of giving away. So these questions are very similar to ones I've seen on quiz one, on the test. Okay. Quiz two. More vocabulary. Some of these are pretty easy. Some of them are not so easy. Okay. What is calculus would still be, it would be a level 1 question. What are the two rates of change? What do you think? Sebastian, what are the two rates of change? You're here.
Your IRC and ARC.
Right. Which you will say as their full name, which is average.
Average rate of change and initial rate of change.
And instantaneous rate of change. Okay, but good, you answered it quickly. All right. What are the rates of change? What is the average? So what is the average rate of change? That I consider a little harder thing. What is the average rate of change? Does anyone remember? It's the slope of the something line.
The second line.
Slope of the secant line. So that's a little harder than some of the easier ones. What is the instantaneous rate of change? Woohoo.
Is that the slope of this tangent line?
It's the slope of the tangent line, or it's also velocity, or it's also dy dx. It's also the derivative. Okay. Why did we invent limits is also a little harder, but okay. These are the questions you need to answer quickly. When they start getting a little more complicated, some of these are pretty easy. The easy ones you should know. I ask you all the time, why did we invent limits? So expect that, but what is the derivative is maybe a little too much. Okay, there's a lot of possible answers for that. So, okay, say the derivatives out loud. Okay, so these are derivatives. All these derivatives are evaluated. Don't be surprised if I don't smush a few together. So it might be more than one of these in the same thing. And again, you're reading it. And if you want to in the spot, provided you can write it, but you mustn't write it before you read it. You have to say what I want to hear you say the derivative of f of x. And by the way, there's lots of ways of saying this that are acceptable. But so don't think this is as hard as it looks, although this last question is tricky. But if you see a prime, you can usually say prime. You don't have to say first derivative. You could say f prime of 1. Okay, if you put a 1 in front, that doesn't mean anything. But if you say f prime evaluate, you could say evaluated at 1. You could say the derivative of f evaluated at 1. You don't. Those are all acceptable answers. If you know what they mean and you're conveying it precisely, then you're fine. Okay. If you don't, for example, this question here that has the derivative, the derivative with respect to x evaluated at x equals 1. You could say it that way, or you could just say the derivative evaluated at 1. That would be fine too. I'm not usually as fussy about those as you would think I would be, because there's so many ways of saying them, and I'll be listening to you, so it'll be easier. Okay, again, these are questions. These are the ones where you have, I don't want to say anything more about those. Unless somebody needs to see them. Look, you can always, you had this test, it actually already, these quizzes, you should have had all of the, I will say, when you click on this, it gives you all of these. You could look at all of them and you could answer all of them. That's the definition of derivative. That's a tangent line. That's a power rule. This is a power rule. This is a quotient rule.
Is there an easier way to recognize like the power rule or the quotient rule or any type of rule?
There's no easy way. No, there is. Well, because the quotient rule looks like this. It's the bottom times. I mean, I'm not. I'm not making you do the quotient rule. I'm just making you identify it. But when it's written this way, it is just the quotient rule. If you see derivatives that are still sitting there, it means I didn't do the other rules. I only did the quotient rule. This guy right here, I only did the product rule. I didn't take any more derivatives yet. Okay. If I go on any further, then if you see something like instead of this, you see 2x, well, now I did a product. Now I did a power rule. Okay, I did product rule and a power rule, but you're not going to see anything. I'm not trying to trick you so much here. These are not the hard ones. That's why I wasn't going to go over them. The group 3 is, quiz 3 is a little harder. Okay, so now these questions are the things you could be asked to calculate. So let's see. Find the tangent line and give it in this form. Now remember, for these questions, you don't say anything. You do all your work on Desmos, and then you put your answers into those slots. And for that, the slots are graded. Okay. Same with the last ones with the multiple answer ones. There's nothing to say. This one, there's something to do. You have to show some calculations. You can't just know what A, B, and C are. How do you find the equation of a tangent line? Anyone? This one doesn't have a formula sheet in it. The formula sheet actually has, if I find the formula sheet, I can find the line. This is the formula sheet. This is the formula sheet. No. All right, where's the formula sheet? Well, I don't know. The formula sheet actually says, let me just, I'll use this one. Formula sheet for, what am I doing? The tangent line will be something in the formula sheet that looks like this. L of x equals f prime of a times x minus a plus f of a. Okay, and if you, I guess I don't understand question mark. Oh. Okay, now what? Too many variables. Okay, now what? Try defining a. Oh. So you have to pick, what did it say? The tangent line at where? At x equals -7. So you can plug in a, make a be equal to -7. Okay. Oh, I don't have the function yet, do I? The function. Where is the function? X squared minus 3x. There's the function. This should be f of x defined in more than one place. Okay, so I just have to put a 1 next to it. So there's the function, there's the tangent line. So, but they don't ask you to find the tangent line, they ask you to fill in the slots. So you're gonna have to find out what f1 of a is. Okay. That's one of the slots, the 70. F prime of a is another slot that's -17. And then that when you plug that right there's just going to be -7. So when you go back to the problem, you're gonna put in, so the B right there, that's the derivative one. The C is -7, and then the A is the function one. So the A was the function one, that was 70, I believe. Oops. After that, that's 70, and the derivative was the -17. So the answer is, you're gonna put in for A, you're gonna put in something 70. And then for B, it's going to be -17. And for C, it's going to be, there's a minus there, but you still put -7. Okay, so that's the slope of the tangent line if they say fill in the blanks. Again, you don't have to say this, you just fill in the blanks. Okay? All right. Any other questions on that? That was the tangent line.
Can you
Pro-
read, can you do another one, please? I still don't get it.
What?
Can you do another one?
Another tangent line one? Okay. So if they give you a different function, there's a different function, and they say they want it at x equals 2. Now let's go with x equals -2. Okay, then what you need to do is you need to evaluate the function at -2. And that's -6, and you need to evaluate the derivative. I mean, you could do the derivative f1 prime equals, you could do the derivative, it's just 2x plus 5. And then you can evaluate that if you want f prime 1 prime of -2. That's going to be 2 equal signs. Okay, what is that going to be, Acacia? -4 plus 5 is what? Oh, it says it right there, it's 1. Okay, so I have the function and I have the derivative. Okay, so now what do I have to do? I have to put it in the form of a line, and the way it says it is, it says y minus a equals b times x minus c. Okay, so for the line, the b is the slope. So the slope of the tangent line is going to be that guy right there. So it's just going to be 1. Okay. The c value is where you're evaluating it at, which would be -2. And the a value is the function evaluated at -2, so that would be -6. Okay, if you do it right, you see the black line, you can see that the red line is tangent to it right there at -2. Okay. You can mix doing it by hand or doing it with the formula, but you need to understand what it is, and it would be nice if you saw the picture that it actually worked. Okay. Okay, can I move on? Oh, look at that, there's epsilon deltas in this question. I told the other class there weren't any. Well, there won't be. They ain't on this test. Okay, but this one could be. Pretty sure I saw this one. Fill in the blanks for the following derivatives. Boom, 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 boom. Okay, so this one does not need a worksheet. Fill in the blanks for the following derivatives, but this is a product rule. Okay, this is a product. So you're going to use the product rule. Then the product rule says the first times derivative of the second plus the second times derivative of the first. So if this right here is x squared plus 3, and that's x squared plus 3, then a is going to be the derivative of this. So if I wonder what a is, bracket A is equal to derivative of that. Okay, and then bracket B is going to be equal to the derivative of what? Anyone? Luke? It's the first times derivative of the second plus the second times the derivative of the first, which is the first.
X squared plus 3, so it would just be 2x.
There you go. So really, right, so that's equal to 2x. And this one right here is equal to what? The derivative of 4x squared is 8x more. Let's see. Okay. And that's what you do. You put the 2x in here. And you put the 8 minus 6x in there. Okay. Just a simple chain rule sort of thing. Not supposed to be hard, but if you do it on Desmos, which you should because you can't do this, I'm editing the problem. If you do it on Desmos, you should check to make sure that you got the right answer. Okay. Okay, any questions on that one? I'm moving on to the next one, which is display type. Full text. Okay, I don't know if I said this or not, so I should tell you now. I kind of lied because, but I didn't tell you professors always lie. So I said there were 15 questions. There's really 17 questions. Okay, so the last question is not a question. The last question is put your Desmos links in here. So that's not worth anything and it's not really a question. So there's really only 16 questions. So who gets the extra question? The group 4s get an extra question. So that one that I just asked. So this is a group 4 one. We have to calculate a limit. Calculating the average rate of change, calculate a limit using finding a derivative. These are all things that you might get one extra problem on. Yes.
The test tomorrow, is it going to be just on derivatives or is there going to be questions?
On limits.
So limits and derivatives?
Limits, derivatives, average rate of change. They're all related to derivative, that's fine. It's just everything from mod 1 to 4. That's why I'm going over these. It's these questions. It's these questions. Okay. So here's a limit question. And here's a sale. So what do you do for limit? This is again a group 5 thing. So this is the limit as it goes to 7. So let me just, to get the 7, I just plug 7 into the table. Some people will sit here and scroll around and go, do. That's fine. Okay, there, you can do it that way too sometimes. 7, 734. Okay, so now what do you say? What are you saying if you are writing if you're the writer? You're writing the limit as x goes to 7. And by the way, that's $7. If you want to say that, that would be nice. The limit as x goes to $7 of f of x equals 723 items. Okay, so okay, that's the writer. What does the speaker say? Who's going to help me with this speaking? Jonathan, what does the speaker say? Begins with an A.
You got me on one I don't know.
According.
Oh, according to the, is it a quartic regression?
It is.
Or I don't, when the price increases to $7.
Right, yes. As it approaches $7. Sounds good. Go on.
approximately 723 units will be sold.
Yep, there you go. Okay, something like that. I like how you said it. I don't have to grade your grammar or anything. If you convey the information, that's fine. Got it? Are we good? No, why it says 8 people are here and I only see. Oh, there we are. Lonnie is missing. Okay. Any questions on that? And you present this. I listened for these things being said at the end of the question. So again, make sure you answer your final answer. Okay. Here it is. Actually, this problem actually says how to say it. According to the, can't promise that you're just going to say that. According to the blank regression, as we approach a blank and blank, blank, blank. Okay. Don't know how those are going to read. Okay, question number, that was 5. What quiz are we on? This was quiz 2? 2. All right. I need to get to quiz 3. A lot of people that aren't here. It's going to be fun when they take the test tomorrow. So I'm sort of helping you out a little bit. What am I looking for? Sorry, Joe's. There we go. Quiz 3, multiple choice. Okay, more vocabulary. Vocabulary that you might be asked. What do we need for continuity? That's a pretty hard one. Function exists, the limit exists, function equals the limit. Okay. Other ways of saying instantaneous rate of change, derivative, slope of tangent line, DYDX. Does the power rule say? That's different. Product rule, quotient rule. Oh, you could be at those would be any of these 4 would be level 3 though. Those would be of the hardest to type because there's a lot of ways to say them. You're going to screw them up. What does the power rule say? Anybody? Pavani, do you know what the power rule says for x to the n? N times what? How about Pam? Pam, it's derivative of a power x to the n.
What? Can you repeat that again? Sorry.
Derivative of a power. What's the power rule say? You have x nth power. What is the derivative?
Nth power. It would be x to the nth minus 1.
Yep, that's it. N x to the n minus 1. Okay. And then there's the mean value theorem. What does that say? That's another one that could be asked. All right. All right. That's when the mean value theorem is when the derivative equals the average rate of change. The instantaneous rate of change equals average rate of change. All right. More things to say, more derivatives to say. Not too hard. More what happened here. Look at the lines. Tell me what happened. Okay. All right.
I'm not gonna get some of those.
You want me to show you one of those?
Yes, please.
Okay. Okay. What happened here was if you have an S of t, that's a position function. So you're taking the derivative of it. So it must be velocity. This looks like, what is that? They wrote this as 8 times x squared plus 2 base to the 1 divided by 2. Okay, that's algebra. That's algebra. You don't have to say algebra, but what did they do? What's the next line say? They found the derivative. And how did they find it? Using what rules? Okay, Keisha, this is your question. What rules did they use? Oh, that's -1/2. Sorry, hold on. What rule brings the -1/2 down? And
The-
then
Is it the power rule?
it is the power rule, brings the 1/2 down and then subtracts 1 from it. Very good. And then what happens when you leave something alone on the inside and then you later on take the derivative of it? What rule's that? What rule was the one where you leave it alone and
The
then
chain rule?
that's it? See, in case you know what you're doing. So that's a power and chain rule question. So you check power and chain.
I mean, when you ask it like, but the question's not gonna ask it like that. I can't just look at it and see. It's gonna take me a while to get it.
Okay, but this is not a timed one. You can take as much time as you want on this one. Well, within reason. We'll test this time, but it's not one you have to do quickly. And there's choices, and you can read the choices. If you read the choices on this one, for example, let me edit it so you can see the choices. The choices are, so one of the choices could be use the position function to find the velocity. Okay. Chain and power rule. Well, that's that one. Okay, product rule or quotient rule only. So that was neither of those. Derivative of natural exponent in the chain rule. Okay. Well, I don't know what that is. The chain rule and the derivative of natural log. Okay, was none of those. It can only really be the one that we just said, just the power rule and the quotient. Not power rule and chain rule. Okay. Let's see what else we have. What's this one here? 8. What's line 8 and 9? What's that rule? Anyone? Pam, you haven't answered one yet. What rule is that?
Product rule?
That's all it is. Nothing else. They didn't actually take the derivative. They first time to it was second. That's all they did. Product rule only. Okay, how about this one? I see an inside function that's been left alone. And it's an exponent. That's the natural exponent. So it's the derivative of the natural exponent. Under what rule? What gives you that piece at the end? It wasn't there before. You did something. What rule did you use? Anyone?
The power rule.
No. I left the inside alone and now I'm taking the derivative of it. What rule was that?
Chain rule?
Chain rule. That's a chain rule. So it's not a power, it's remember one of them said derivative of the natural exponent and then a chain rule. This is the derivative. That's the natural exponent. One of them also said derivative of natural log. There's a natural log. So this must be the other one. Derivative of natural log is 1 over x to the 4th. And then the chain rule is that piece right there. Okay. What is 17 to 19? Ooh, that's tricky. So what does this formula right here look like? With the G of 5 and the G of 0 and the 5 minus 0. What is that a formula for? It is for average rate of change. And Sebastian, what does G prime mean? Which rate of change is that? And they're equal to each other. What rule sets average rate of change equals to instantaneous rate of change? It's a theorem.
Or limit theorem?
No, it's not so nice. It's a value that's not so nice. Which value theorem was not so nice? The mean value theorem. There you go. Are you a crossword puzzle doer? That was a crossword puzzle question. Yes, that's the mean value theorem. And that would be one of your choices if that was your problem. Okay, how about this one? I see there's a power to the 11th and now it's to the 10th. So what rule do you think that was? Power. And then now you're taking the derivative of the inside. So what's doing that? Power and chain. Power and chain. And what about this last one? Acacia, what's this last one? It's just something. What is it?
The quotient rule?
That's it, just the quotient rule. Very good. Question number 3. All right, moving on to question number 4. Oh. Well, now you get to do one of those chain rules. Okay. Or you get to take, okay, look at all these derivatives. You get to take a derivative up. So these are all derivatives. So basically just find the derivatives. Okay, so I'm going to copy this down and see if I can put it here. My decimals. Oh, I can't. Maybe I can. Find the derivative using the chain rule. Okay, so this is to the 6th power. Raised to the 6th power, and this is raised to the 9th power. So let me, let's find the derivative. So if I do y equals x, parentheses, x raised to the 6th plus x plus 14. And that's all raised to the 9th. How do I take the derivative? So there's the function in black. Let me get rid of these other things here. Okay, so there's my function. It's really hard to see. I'm just going to make it so we can see it. But you don't have to do this, so please don't do this. Right. That's the function. Oh, because it's not right. That's why it's not right. Hold on. Let me go back here. There it is. I had to make the window so big. That's why I'm saying don't do that. That function does not graph nicely. Okay? Now, I want the derivative of that. Okay? So I've got to take the derivative. So I'm just going to write it down. Watch this. dx of that. So that's the red function. Okay, now we can just check and see if it's right. What rule do we do first? How do we take the derivative of that? Oh, by the way, there's supposed to be 3 in front. So hold on. 3 and 3. Okay, so what do we do first? When taking the derivative of a power, first of all, the 3 hangs out. What do we do? Is this a power? What do we do? We have a power. So what's the derivative of something to the 9th power? 9. What do we put on the inside? All of that. So we're leaving that alone, right? We're raising it to what power? Yep, that's the power rule. Still not right. So that's not the right answer because the red, they're supposed to be, the blue is not the same as the red. So what do we have to do?
Where did the 8 come from?
The 8, the power rule, you take 9 and you subtract 1 from it.
Oh.
Power rule, you bring the 9 down and subtract 1. Now, what do we have to do? We have to also take the derivative of what? Multiply it. Sebastian, did you tell me the derivative, what the chain rule was? I feel like you did. Somebody did. Now I have to take the derivative. Do you see how now the blue and the red are the same? So that's definitely the answer. But I can't leave it that way. Okay. I have 27 here. Okay, what else do I have? I have this thing, the eighth part. What's the derivative? Can you tell me what that is? What's the derivative of x to the 6? What's the derivative of this and the derivative of that and the derivative of that?
6x to the fifth.
6x to the 5th. What's the derivative of x?
1.
1. What's the derivative of 14?
0.
Okay, so those are the things. You have to put 27 in the first spot. You have to put all of this in the second spot. You have to put that in the third spot and that in the fourth spot. So let's see. So you'll see the answer looks like this. 27 for A. B is this thing, x to the 6 plus x plus 14. C is 8. And D is 6x to the 5th plus 1. Okay. Questions on that? You have to answer these questions. You have to put the answers into those questions. Because that's a writing problem. All right, what else do we do? Chain. All right, how do we do the derivative of 9? How do we do the derivative of the 7 sine squared of x? 7 sine squared of x. Okay, what do I do? Someone's got to tell me what to do, because this is a very popular question. What would you do? How would you start this? Power first. This is the same as 7 times sine of x, the whole quantity squared, like that. So the power is the outside thing. So what is the power? We're going to tell you. It's going to be bring the 2 down, multiply by the 7, and you get what? 14 sine of x raised to what power? 1 power times derivative sine of x. Okay. What's the derivative of sine of x? So it's 14 sine of x, because the first power, I just dropped that, cosine. Okay. And that's the answer for that one. Yes,
Do you have to put that 1 up in the power?
nope. That's why the answer, I took it away. The answer is, yeah, it's a simple answer, 14 sine x cosine x. Okay. Easy enough. Okay. What else do we do? Oh, I picked it wrong. Sorry, hold on. I know there's more. So there was chain rule, there was cosine squared or sine squared or sine squared. And then there was derivative of an exponential. Okay, so this is an exponential function. So this one's a little easier. It's the derivative of 3e to the 5x plus 1. Do you remember before? What that means? The derivative of e to the something is. Who had that question? Losing my mind. Which one of you people at home had that question? Oh, Safla's here. Hi, Safla. Who had this question? Derivative of e to something. Was it Luke? Luke. What's the derivative of e to the something? What's the derivative of e to the something? Anyone? Let me hold on a second. Now you're making me look.
E to the x.
Right. So the derivative of e to the something is going to be the constant. It's going to be e raised to the. I'm just going to leave that something in there. 5x plus 1, because the derivative of e to the x is e to the x. There's something in there, you leave it in there, and then what do? You multiply it by the derivative. What's the derivative of 5x plus 1?
Just 5.
Okay. That's why the answer is 15. Where's the answer? 15 e to the 5x plus 1. Okay. Those are the last things you could be asked. Those are just, so this is a derivatives test. One of the questions will probably be to do one of these derivatives. Okay. Probably. All right, last one on this. This is test 3. Flu. Here. Okay, so predict the flu values. So let me go in here, full text, click on that. So they're telling you to predict the flu. Oh, it says 2. So it says f of 2, f prime of 2, f double prime of 2. So this must be one of those derivative ones. So the first one was a limit. Definitely had an average rate of change. You had a limit, and now this is a derivative. So let's see what that looks like. So they give you a table here. All you have to do is type in the number 2, and that gives you all the function, the first derivative, second derivative. Now, if you're the writer, you write f of 2 equals 350. 350 what? Outbreaks? Okay. F prime of 2 equals what? 29 outbreaks. For what?
Per year, per month.
Okay. And the last one is f double prime is 125. Negative 125. Outbreaks per month, what? Okay, so if you are the writer, that's how you say it. You say f of 2 equals 350 outbreaks, f prime of 2 equals 329 outbreaks, f double prime of 2 equals minus 108 outbreaks per month. Okay? Now, what about the speaker? What do they say? Begins with an A. Thank you. According to the Bordick regression, what?
The second one,
In the second month. Keep going, please.
there will be an average increase.
No.
There'll be 350 outbreaks.
Yep.
Increasing at a rate of 329 outbreaks per month.
Okay,
And decelerating at a rate of 125 outbreaks per month.
and decelerating. Fine. Outbreaks per month. Don't use abbreviations. But you have to, on the test, you have to say them. Okay? Not hard? Okay. Look, if you're lucky, the problems actually give you some hints, like saying according to that, they actually tell you that, if you're lucky. But if they don't, just make sure you say as best you can. I can't promise that it's going to say. Fill in the blanks. Okay? All right, let's move on to the last quiz, quiz 4. Okay, again, vocabulary. What's the derivative of what is the derivative of hyperbolic sine?
Hyperbolic cosine.
Thank you. What is acceleration? Acceleration?
Second derivative.
Second derivative. What does Newton's method do?
Find zeros.
Find zeros. Yep, very good. So that's vocabulary. All right, say these higher forms. So here's what people are going to miss on this one. So for these, this is higher order formulas. And by the way, I could mix higher order formulas. Like you see how this has derivative of sinh and cos in it that you have to say correctly, or hyperbolic sine, hyperbolic cosine. But you see that last part, G? How would you say this one right here? Anyone want to say this?
Yes.
Go ahead, say it. Christian.
The derivative of hyperbolic sine with relation to x equals hyperbolic cosine with relation to x plus the derivative of g.
There you go, plus the fourth derivative of G. How about this second one, that last part, the G? How would you say that with that right there, the end part? You don't have to actually say the whole thing. What does it say? That's nasty. Not you, Christian. Oh, Christian, go ahead, say it if you want.
Okay, the derivative of hyperbolic sine with relation to the inner function of hyperbolic cosine equals hyperbolic cosine with relation to the inner function of
Oh my
hyperbolic.
God, you're doing this one down here. Okay. Don't do that one. So there's something wrong with it. Sorry, Christian. Now, I really wanted you to do this one right here. Let me put it up at the top because I can't mark it. Do you see the top one? This guy, just mark it. So I wanted you to do this one. Hold on. There's two problems here, this and that. This right here says what? First one in the first circle. That's what derivative? That's what derivative. And this one right here with the two primes is what?
Second
Derivative, or you could say double prime. Okay, but do not say quotation marks or anything. And all of these hyperbolic things, you can't say, look, you want to impress me on an interview that you don't know what you're talking about, say sine H or cosine H. Don't say the H's. If you have tan H, that's hyperbolic tangent. Okay, don't say tan H.
How cosine is cos and sine is sinh. What is the
It's hyperbolic tangent. You know what? I don't know all the answers to the world, but I went to Google and I asked, how do you say COSH in math? And it had a little video on YouTube where they said it. Where's my little video on YouTube here?
There is no definitive pronunciation of these things. You can pronounce them however you want because there's no official way to do it. I like Shine because I think Shine is a really,
Really?
with some
Okay.
exceptions that we'll talk about.
You can
they
find
more or
anything on the
less-
internet. No, but they're Cinch and Kosh, but the hyperbolic. I don't know who this guy is. Sorry. Oh, it's down.
Hello there guys and welcome back to another Epic Electrical Maths video. In this video we're looking at hyperbolic functions. Now you've probably never seen hyperbolic functions.
Okay, anyway, I went online and I looked because I've only ever heard Kosh and Cinch mentioned. I've never heard the other ones you can't say. How are you gonna say that? Tanha, Sikha, Kosika. That's just, there's no way to say it. But Cinch and Kosh. I guess all I'm saying is I've heard Cinch and Kosh. That's the only ones I've heard. Anything else? And by the way, I have never seen any of the other ones used in anywhere anyway. So I'm less likely to ever even bring them up. Okay. All right. Sorry about that. Well, more of these. Acacia, do I have to do more of these? Or are you getting the idea?
I get it.
Okay, look, there's the derivative of, that's just a chain, a power rule and a chain rule. That's a fourth derivative. That's implicit differentiation. That's acceleration from a position function. That's implicit differentiation. Implicit differentiation. Second derivative. Oh, what's this one? Lines 23 to 25. What is it? Anyone? It's a method. There's 3 lines here, so it's not that easy. I'm trying to find the zero of a function. You told me what a zero function is. What was that finds the zero of a function?
So
That's Newton's method. That's what this is. Okay. That's a power in a chain. It's in, oh, so this one right here. Oh, there's a product rule. This has a lot of nasties in it, I think. It has a product rule and a chain rule. And a power rule. No powers, just a product and a chain. But I think one of the other ones has a. Oh, so this one is Newton's method again. Okay, so this guy right here. No, it doesn't have a power. This one's just implicit differentiation. Okay. Any questions on those? You know, I went through them quickly, but I don't. But that's
Yes, I do.
what? What's your question, Christian?
Yeah, anytime there's an X and Y together, that's always the and always going to be a product rule.
X times Y is product rule.
Okay.
It's never not a product rule. Those are two things multiplied together, and there's no way that you can take the derivative. Okay, I'm not going to say that. If you're taking a partial derivative, then it's not a product rule. But partial derivatives account 3 things. In this class, no. Okay, those are 2 variables or functions or both. Okay, here's one way it's not a product rule. There, pi is a constant. So if it's 2 pi x, that's a constant. Here's another one that's not a product rule, 2ex, E is a constant. Okay, ax is also not a product rule if they tell you a is a constant. But if there's a w there, that's usually a variable. That would be a product rule. Okay, if there's 2 variables there, there are 3 variables, that's going to be a product rule twice. That's ugly. Let's hope nobody ever asks you that. Happens. Did I answer your question, Christian?
Yes, thank you.
All right. Question type 4 again. Find the derivative of a hyperbolic implicit. Okay, so there's 3 here. I feel like we've done some of these or seen them. So, like, the derivative of the hyperbolic. So this looks exactly like, and I've seen this on tests. This looks exactly like the one we just did, only it's a hyperbolic sign. So I tell you, I know what the answer to this is going to be. What? Oh, it's harder. Sorry, my bad. This is harder than the one we had. Why? Remember that too? Remember we said, oh, that's the power rule first. I remember especially you said it. Then you said, what do we do first? The power rule. So if the derivative, so you're going to bring the 2 down, and the inside function is the hyperbolic sine 5x raised to, remember, didn't you say the first power, raise it to the first power, and you don't have, that's the power rule, yes? And you asked me, do you have to put the 1 in? And I said, no, but I'm putting it there just to show you how exactly the same as this times the derivative of 1 times dtx of everything that's in there. Just copy and paste the piece here. Okay. I know we did this exact same thing, except it wasn't hyperbolic sine. It was just sine, right? So now what's the derivative? And I didn't do anything but the sine. Now I'm taking the derivative of hyperbolic sine. What's the derivative of hyperbolic sine? Hyperbolic cosine. So I take the derivative, take it away, and this becomes cosh. Uh-oh, there's stuff in there. What rule applies if you have stuff in there that isn't just x? What do you have to do? You leave the inside alone, and then you do what with it? Then you take the derivative of it. Okay. And so what's the final answer going to be? What's the derivative of 5x? That's just 5. So now you can combine the 5 and the 2, and you can clean it up, and you get 10. And then you have sinh of 5x. Cosh of 5x. Okay. And that's it. And you could use Desmos to figure it out. Okay. Okay. What about the tangent line for a point on the ellipse? Okay, so tangent line on an ellipse. So ellipse looks something like this. Okay, there's an ellipse. Okay, does everyone see the ellipse? No. I don't see. Wow, that's a messed up ellipse. What? Oh, because it is. Oh, hold on. It's not an ellipse. Those are just vertical lines. There we go. There's an ellipse. Everyone see it? Are you happy?
Yes.
Okay, then they're going to say at a point. So I'll just put that in the next line. Put it in quotes. At a point. 2, 1. Okay. That a point there? 2. Oh, I'm sorry. I gotta make it bigger. 2, 1 would be 4. It would be 7. There we go. I have to have 2, 1 has to be on the ellipse. So there's a point right there. 2, 1 on the ellipse. Got it. Point, ellipse. This is the question. So now it's the question is how do we find the slope of the tangent line there? So we're going to do what to this equation? To find derivatives, what do we do? Slope of the tangent line, derivatives, what do we do? What do we do to find derivatives? Take the derivative.
Yes.
So let's just do that. Uh-oh, I have to use what rule if I'm going to take the derivative? I have an equation with y in it. Can I just take derivative of each one? That's implicit differentiation, right? Are we good with that? Okay. It's the derivative of x squared. Two
X.
2x. Got it. What's the derivative of 7? Got it. What's the derivative of 3y squared?
6y.
6y? Okay. I don't, something's missing. Where's my derivative? I'm solving for a derivative. When I go to put the points 2, 1 in there, okay, if I just try to use those points, I plug in 2 for here. Okay, that's for x. And I plug in 1 for there. I got nothing to do. Where's my derivative? What, you think the answer is 4 plus 6? That would be 10. The slope of that line is not 10. The tangent line is slope is not 10, but there's it should look something like that. So what do I do? 2x plus 6y what? This was a chain rule. These variables don't match. Okay. If this had been a y like that, then the answer would have been 2y, little y. If that had been a little y, then the answer would be 2y. But since the variables don't match, that means it's a chain rule. That means you're bringing a 2 down, making a 6y, subtracting a power, and then you tend to take the derivative of the inside. Okay, now when I plug in the 2 and the 1, I do have something to solve for. And it's that. And I can solve for dy dx by saying it's equal to -4 divided by 6. Okay. Now, if I want to see the tangent line, they didn't ask, but that's the answer, -4/6, and you're done. If I want to see the tangent line, it's going to be y minus the y value, which is 1. Equals derivative, which is -4/6 times x minus the x value, which is 2. Does that look like a tangent line?
Yes, it does.
Don't have to do it. I just wanted you to see it. This was not required, but you will have to do a tangent line equation with a tangent line, just not on this problem. Okay, Newton's method. Did we do Newton's method yet?
A little bit.
Let's just do it here then. So Newton's method, if I go all the way to the top, I can get from the formulas, I can get Newton's formulas right there. All the way back down to the bottom. Okay, so Newton's method. Get rid of these. All right, so Newton's. I got that. And I have some. They want me to solve some equation, x cubed minus 2x plus 5. Okay, whatever. They want me to find this number right here to 6 decimal places. I only have 5 decimal places. Okay. So I could do this. I could do that minus f of that divided by f prime of that. I could just do that, and it's not working because I didn't set this equal to f of x, sorry. Okay, now it gave me virtually the same answer. I could be done. Okay. Or I could say z of x equals this, and then I could just do z of that number that we just got, and you see it gives you the same answer. But the important thing is I can do z as many times. If I have to do it again, did the number change any? No. Having 5 decimal places as a starting guess is really good. If I'd started with -2, that wouldn't have been such a great. It would not have been a great guess, and I would have had 2.1, and then I would have to repeat this again and again. So if I start with 2 to get the answer, I have to do z again, z again, z again, and then eventually I get the right answer. Okay, that's Newton's method. Any questions on that? It's an application of derivatives. All right, last question.
I-
Go ahead.
Yeah, thank you. So Newton's method, the Z variable you're using is set to find a third axis, like a third vector.
A what?
That Z, the Z letter you're using is to find a third, a vector or a third, three-dimensional axis.
I just don't want to type in the X all those times. So I
Oh, okay.
created a new function that says if I just put that number into Z, it's going to put it there, there, and there. It's just going to do it for me. So look, let me just get rid of all these Z's. So I can either put the -2 into all of these spots and get -2.1, or I can just say Z of -2.1, and it just does it automatically.
Oh, okay.
It's an application of derivative because there's the derivative right there in the bottom. You could, some people do this, I don't know why, because it's not necessary. They say, I want to create the function, but I'm going to put the function in here. And I'm going to put the derivative in there. I'm going to show Professor Porter that I know how to get the derivative. And it's that. And that's the same thing. It's just a new function that looks now, it just looks messier, but it's the same idea. So nothing's changed. But if I want to do this process again and again and again, I can just do Z of Z of Z, and eventually it'll find the answer. It's a good way to get, it's not actually found it a long time ago. I just kept typing in Z just to be sure. Okay. All right, Christian, let me get to the last one. Sunflowers. Okay, so this is the same as the other one, except the period is it's a sign regression. So when you do the sunflowers one, and they say do it at the whatever third week or something. Okay, there's the third week. But you have to graph the function and tell me the period, because it's not going to be just according to the sign regression. It's going to be according to the sign regression with a period of what? What's the period here? What do you think? 20. So according to the sign regression with a period of 20, in week 3, sunflowers are 66 centimeters high, and they're growing at 30 centimeters per week, and they're accelerating at 3 centimeters per week Okay.
So you don't round, you just give the whole numbers?
Somebody asked me in the other class to be more clear about whether you want whole numbers or numbers to the or decimal places. If you're saying it, I generally want whole numbers. If you're the speaker, I want whole numbers. If you're the writer, like you would be in this problem right here, then I probably will want at least 1 decimal place. Okay?
Okay.
But I should say it. I'll try to look over the test and make sure that it says that clearly. Okay? Any other questions before I move on? Oh, that's it. That's the last one. All right. I'm done with this though. That's what the test looks like. Any questions on the test? It starts tonight at midnight, goes till midnight tomorrow. You're going to access it by going to the test. You click on the test and it will automatically zip you into HonorLock. If you have any problems, you reach me by phone. You either text me or call me, but you do not send me an email saying, hey, Professor Porter, there's a complete disaster now and I can't take the test, because I may not see your email. Okay, I give you my cell phone number because I want you to use it. Okay, if it's an HonorLock issue, you could contact HonorLock. They have a chat at the bottom. If it's a Mercer Online thing, you can contact Mercer Online, but they may not get back to you soon enough. So always try HonorLock first, because they have a live person there all the time. We paid them money for that. Okay? All right. Any other questions about the test? How does it seem? Does it seem difficult? Has this helped you at all?
It is difficult. It's a bunch of stuff. It's a lot to remember.
It's the same stuff. Hopefully it will help you. It's going to be harder with the midterm because there'll be more stuff. Okay? More stuff. Okay.
Well, that sucks.
Well, you didn't learn anything from this derivative stuff? Nothing? You don't have to be honest.
I learned a lot tonight, but to find the like, I don't know.
Okay, well, it's okay.
What is the pass mark though?
What is what?
The high, like the highest score we should get to pass the test.
To pass this course, you need a 65.
65.
Believe it or
Okay.
not, it's not. So listen, you raise a good question. Some of those problems that you think you should study are only worth 20-25% of the grade. All the things that I keep asking you, what's calculus, what is that? Those things are worth a lot, considering that they're worth about the same. They're worth the same points as the other questions are. So if you can answer the fundamental questions that I ask you that don't require a whole lot of calculations, some of these calculation things you can let go. And you may not even, they may not even come up. I went over all the examples that clearly the calculations ones were the hardest. But if you miss all of them, you could still get 75-80% on the test. If you miss all of them, but you've got to get all the other ones. So you have to be able to, you need to know the vocabulary, you need to read the stuff out loud, you need to write the stuff, well, you know, write stuff, you need to comprehend what you're reading, and you need to present stuff. But as far as doing the calculations, that's just one of the 5 types of questions that are on there. Okay? And you should be able to get some of them even without too much difficulty. But if there's a hard one, you can't skip it and come back to it. That's the only thing. You do it or you don't, but you can't go back to it. Okay? Let me just say something about the last stuff because I only have 12 minutes and I didn't cover last time. Did I do related rates? And I hope I did local linear approximation and related rates last time. I left you out a little early, so I must have done them. Error I'm going to discuss next time, but the thing that I was going to go over is the only thing that's on your home. So let me quickly go to your homework. Where is your homework? Here it is. No, that's not it. It's here. Okay, so homework questions. These are related rate questions, every one of them. And I go over them next time in more detail if you need help, meaning next time after the derivatives test. But these are wordy word problems on related rates. Well, here's one that's a linear approximation. So there's related rate stuff and linear approximation stuff that we did last time. Good luck with you. Try to get them. That's the best I can tell you. But what I didn't go over last time at all was the derivative of inverse trig functions, but they're not difficult. That right there with sine to the -1, that's an inverse sine. The derivative of inverse sine is on that list. Remember I gave you on the notes, I said these are things, not that you have to know them, they're on a table because they've already been done. Somebody used implicit differentiation to figure out what the derivative of the inverse sine was. Okay? If I had all the time in the world, I would show you that proof, but you can watch it on YouTube. But right here is the derivative of inverse sine. It's equal to 1, just like the derivative of natural log of x is 1 over x, the derivative of the inverse sine is 1 over the square root of 1 minus x squared. Okay, these are all, there's inverse cosine, there's inverse tangent, and so on. Okay, these are all just, they're all in the table. Okay, I don't require that you memorize them. They're not worth memorizing. If you're going to Calc 2, you'll probably memorize some of these. But you will have to rememorize them because you will have forgotten them. Okay? All right, so let's see, when the homework says find the derivative of the inverse sine of that, the derivative of inverse sine is 1 over the square root of 1 minus x squared. Now, here's the one thing you need to know. If you're leaving the function on the inside alone, remember how we left things alone and then we took the derivative like, you have to put it in where you see x. So that's where it goes, right there. And then you multiply it by, the chain rule says, the derivative of that. Okay, the derivative of the inverse sine of the cosine of x is 1 over the square root of 1 minus cosine x squared times the derivative of cosine x squared. It's interesting that it does that. That's a very weird thing that it does. Because you know what would happen if I put a sine in there? That would be 1 over the sine of x times the derivative of the sine of x. Right? Anyway, it's either 1 or -1, depending on what x is. But inverse sine of sine they should cancel each other out. It should compose the function with this inverse. But it doesn't. All right, again, there's a function. If this is another chain rule, you use the inverse function. This is just a power rule for this one right here. Again, you need to know this, Acacia. You're taking the derivative of this. What do you do first? What's the outermost function?
The line, the power, I don't know.
The 9, the power rule. Thank you. You're saying it. Don't say you don't know it when you know it. She knows it. It's the power rule. And then I leave the inside alone. So it's to the what power now? Power rule says bring
8.
the 9 to the 8th
Oh.
power. 8
Oh, 9. Oh, 8.
times the derivative of the inside. And that you just get from the table. Literally that table of values that I had over there, just copy it down. I don't know what it is. It's where is it?
So maybe keep the table open.
When you're taking the quiz, sure. I don't have any control over your quiz anyway. On the test, no, but on the test, this is not happening on the test. Okay. Or there is one in there. The inverse sine is on your formula sheet, I believe. That's the only one I'll ask you to do. So I'm not going to ask you any of the others. Okay. All right, and that's that. All right. So that's the homework that you have. Don't even try to do the homework until after you have finished the derivatives test. And if you need to take a day to get your thoughts back together before you start on Mod 5, then do that. Okay, I need to ask you some questions.
Oh, Professor, can me and Jonathan speak with you after class, please?
You can, but you're going to have to wait because I'm going to speak to you right now.
Okay.
Where am I? Hold on. I'm taking attendance by doing what? What do? I ask you your lessons. Mod 5. Mod 5. All right, let's ask some questions of this class. Slade, talk to me. Tell me.
One.
How many points do we need to really? Next week, you're going to get a harder question for sure. 1 point you need for instantaneous. Acacia, why did we invent limits? Acacia? Acacia,
I'm here, sorry.
why did we invent limits? Instantaneous
To
rate of
take
change.
the two, yeah,
Yes. Yep.
to take the 2 points of the average rate of change to the 1 point of instantaneous rate of change.
Very good. Justin here? Justin is not here, so. Okay, Cody is not here. Eric, what's the derivative of a constant? Hello, I know you were here. Eric, what's the derivative of a constant? I'm taking up point because you're not answering me. Why don't you answer me in the text? Oh, 0. Why aren't you saying that out loud? Don't be sending me no text messages. I don't need to hear these things. Okay, that's fine. I'm not gonna take out any points. David. David here? No. Aiden here? No. Selena here? No. Garth. Are you here? Did you go to a funeral? Funeral. Oh, too sorry. I'm horrible. Bad man. Okay, Sebastian, you're here. What's the chain rule say?
It says the derivative of the outside leave the inside alone, then multiply by the derivative of the inside.
That's correct. Very good. Pamela, what's the relationship between position, velocity, and acceleration? What's the relationship?
I don't remember.
No. You can't not remember because you didn't remember last time. And I called on you and embarrassed you. So now you have to remember. What's this test called?
Derivative.
Okay, so what do you think the relationship between position, velocity, and acceleration is?
The derivative.
Okay, that's the relationship between position and velocity. What's the relationship between velocity and acceleration? Say it again.
The derivative.
Yes, there you go. Jonathan, what does the MBT say, mean value theorem?
A derivative exists on AB so that it is equal to the average rate of change on AB.
Okay, very good. Pavani, what's the derivative of those things?
Derivative of sinh is cosh, and the derivative of cosh is sinh.
Okay, Alicia, what do we do when we don't have an equation, but we want the derivative?
It's like
It's not explicit.
so it's not
What's the opposite of explicit? It's implicit. Thank you. Carlos, is Carlos here today? Was he here last time? Okay. Luke, what is acceleration? Since Pamela didn't say it explicitly, what is it?
The second derivative.
It is. So that's Pam, do you understand the relationship between position and velocity is first derivative? The relationship between velocity and acceleration is first derivative. The relationship between position and acceleration is second derivative. Okay, and physics people may have invented some of this stuff. Okay, so there's my other class. I don't know. Did we talk about that in this class or the other class? I'm losing my mind. Okay, so what happens is some people argue which came first, physics or math. Well, you know what came first? Physics. You know what they did? They had a problem and they needed to communicate it. So they needed a language. So what did they do? They invented math so that they could talk. So physics is the answer. Okay. One other thing before I let you go that I was telling the other class. They asked me, can I have food or water during the test? And the answer is yes. Oh, keep that bottle up. I need you to answer this question for me. What are the ingredients on that bottle?
I need water,
Water. Keep going.
caramel colored,
Color.
phosphoric acid,
Phosphoric acid.
that's part of it.
Keep going. That's sugar.
Feel
That's
flavors.
natural flavors. Don't drink anything with natural flavors. I don't even want to see them. Natural flavors. Okay, so your brain does two things while you're taking a test. takes the test and it runs your body. Which is more important? No, running your body. The brain has one part of your body is more important than your brain. What part? The brain knows there's one thing that's more important. Yeah, very good. You got it right. The heart is more important than the brain, and the brain knows this. Okay? Yeah, it does. I know you don't think so, but it does. It knows that its oxygen comes from the heart. So anyway, so you don't want to mess with your brain. You don't want to mess with the things that it has to do. Now, I believe, this is just my belief, that you don't want to mess with the brain, so you shouldn't mess with artificial sweeteners and artificial salts. So, artificial sweetener, you know what that is, right? Because that's, you know why you don't want to mess with that? Because the brain eats sugar. That's its food. Besides oxygen, it wants sugar. So, if we have a piece of hard candy if you want, during the test, you're allowed to have that. But nothing more complicated. Because anything more complicated distracts the brain. What about salt? Artificial salt. Why is it important? Because you know what the heart eats? Heart's a muscle. Do you know what muscles eat? What's that thing that you drink when you're sweating a lot and you're working out? Electrolytes. Yeah, electrolytes. Do you know what another word for electrolyte is? Salt. Sodium is one of them. And so when your body eats fake salts, you mess with your brain, and you don't want to do that. Do you know what a fake salt is? Monosodium glutamate. Do you know where it comes from? Soy sauce. Do you know what soy sauce comes from? Soys. Do you know what soy is? Natural. And it adds flavor. So you know what they call that? Natural flavors. It's in every soda. Do not drink soda before a test. Don't even have it during the test. You will mess with your brain, and your brain will not know what to do. Okay? So stay away from that. And there's another thing I don't like you to do. Don't drink soda or coffee or tea or eat melons before a test. Why not? Yeah. No. I mean, I don't care. I don't have a problem with caffeine. Okay, so why should you not drink those things or eat those things? Because they make you have to pee. And maybe not now. But if you have to pee during a test, I used to call this Professor Porter's pee theory. If you have to pee during a test, you don't know that you have to pee, but your brain is pulling away resources. So just have some water, but don't come in. Don't bring a big. I really had a student come to a test with a big gulp that was 3/4 done after I told them not to do this. Just a bottle of water would be nice. Nothing else. Just a hard candy would be nice. Nothing else. Don't mess with your brain during your test. Take the test the way you study for it. Okay? So that's my advice I'm giving you now. Do the best you can. I know you've just succeeded in math so far, so you probably think you don't need any of my advice, but someday you'll say, thank you, Professor Porter, for telling me about that P theory, because I forgot about it. Anyway, go ahead. Have a good night. Have a good weekend. Good luck with your test. I'm hanging around for anybody at home who has questions.
Yes, can you check for a mod 5, please, or graph? Oh, also, on the test, like, speak in inverse strict function,
Yeah, what about it?
will it be on the test for us to say it?
Inverse, it might be. If you say something raised to the -1 power, you have to say inverse.
Okay.
Oh, is that from here? Is that from mod 5? No. No.
Yeah, yeah.
I don't think so. No, I
Oh.
didn't see any inverse signs. Maybe no. No, that was probably on these quiz on this one. I don't think you'll see it.
Okay.
I don't remember seeing an inverse sign. I don't see
No, I
every-
didn't hear you say anything about it.
Yeah, I just went over it at the end. That was mod 5 stuff I went over at the end. I had to finish up.
Okay.
five.
But over
So your graph is under mean value theorem here?
Yeah, I
Which
need you to look at it. I'm not sure about it.
Where are you, Acacia?
Yeah. There's only 2 of us, so
I
I
know.
don't know.
What happened to Cody? I thought he was in for the long run, but he just bailed.
And he been ignoring our messages.
I know. Well, okay, so this is not good because your secant line, the orange secant line is not parallel to your purple line. And the reason it isn't is because 13 is not the right answer. In fact, it's definitely not the right answer. So let me go
Okay.
into your thing here. Since you gave it to me, I might as well show it to you.
Oh, wait, where's the link?
Okay, I need to put it up here. Right. Uh-oh, that wasn't it. Did I miss something? I copied this. Why didn't it work?
I'm wondering too. I'm trying to open it, but it's not.
Oh, there it is. Works now. Okay, so you're going between hours and studying. Is that your problem?
Yeah.
Okay, so now let me just show you something. When you put these on, you were supposed to find where the average rate of change equals the instantaneous rate of change. Where would that be? This is the average rate of change. This is the instantaneous rate of change. Can you identify one? I need to find that first, which you didn't do. So where would that be? I'll give you a hint. Here's one over here that doesn't count. This one, 26.29, not your answer. So where's another one?
Oh.
Okay. Let me just show you why 26.29 is what you want. See how the purple line and the orange line are parallel to each other? That's what you. But the problem is this purple line is tangent outside of the orange line. You need something in between 0 or whatever this is, between, I don't know what that is, 3.5? It can't be 3.5. Probably, I don't know. What are your true values? 1 and 13. So you need numbers between 1 and 13. So you need to tell me where this green line intersects the blue line that's between 1 and 13. Do you see it? You have to.
The green line and the blue line?
The green line and the blue line. Where do they intersect?
Around 10?
Around 10, maybe? Okay, the problem is that purple line's in the way, so let me turn it off. Okay, around 10, like maybe 9.16. Okay. So right here, you're going to write f prime of, I'm going to get that number, 9.1684. I'll put it here, and you will see that they're the same. Average rate of change is equal to instantaneous change. Is there another one? There is. It's over here somewhere, but I'll let you find that. So when you do that, you'll do to write that one too, f prime of that other one. And it'll be the same number, 5.8. Now, I only need one of them to finish this thing. So I got this problem in here copied. Now you need to go down to C0 and put that number in. Okay? When you do that, and you hit enter, why isn't it working? Oh, because I turned it off. There we go. I'm going to turn off the blue line because I don't. Do you see how both these lines are parallel now? Purple line, and you see right here is that 9 point whatever. The other answer, when you do the other answer, it's not going to look as good. It's going to be over here somewhere. Like
I need both of them?
You should find both of them, but don't graph this one because it's really hard to see. So just leave the other one in, whatever that was, 9 point whatever. But find the other one and put it in here, right? F prime of the other one, which you're going to get by turning these on. Where did they go? You have to turn these back on again. This one and that one. and find the intersection. And that intersection is going to be around here somewhere, 2 point whatever, 2.1 something. Okay, so you're gonna put that in there, 2.1 something. See, it's close, but you can do better. Okay. There, 2.216. Now you see how they're getting closer?
Mm-hmm.
624. Now they're really, really close. If you wanted to get closer, do you know what method you could use that would give you more decimal places? What method do you use to get more decimal places? You don't remember?
This one is hard. I barely understand this one.
This one's, but don't worry about it, 'cause it's not on your test. You can do it for next week, but you got the answers for this for now. Publish this. Publish, make sure your thing looks like that. Turn these off. Make sure your graph looks something like that. That's what you want to publish. Okay? If you have this, then Jonathan can reply to you. And he'll say something like, according to the quartic regression, the average rate of change between 0 and, gosh, you have to make sure he knows what numbers they are. So make sure you write that down somewhere, 1 and 13. Okay? Those have to be where they can be seen. So you can move them down here, or you can just, you can either move them down, or you can just put them in here, 13, 1, 13. Then Jonathan can say, according to the quartic regression, with the average rate of change between 13 and 1 is the same as the instantaneous rate of change at 9.16, or that one, 2.2 something. Okay,
Mm-hmm.
Thank you.
does that help? Are you good?
Yeah,
That's
we were talking earlier about, I was like, oh, I don't think our graph is right. We had to figure that out. So we appreciate it.
okay, no problem. That is not on the test tomorrow, so you can fix it after you take the test. Okay,
All right. Thanks so much. I hope you have a nice night.
no problem. You too.
Hi, Professor.
Christian, do you have a question for me? You sure? I'm closing up shop. Last chance. Oh, I can't hear you because your mute is on.
Oh, sorry. Yeah, when is the deadline cutoff? That's tomorrow.
So do you think your class is going to be upset with what I said in this class? Did you hear me?
That's so good.
What?
I hear you.
I changed the way the exam is going to be, so you have to speak more and write less.
Okay.
But I think I'll send those instructions out tonight so people will know in your class that, because a good 60% of the test has to be spoken, which is way different than what you're used to. But that's what this test is all about. After I do this, all the tests after this will be like that, and you'll know what's going on. But I don't want people to be too surprised. I mean, the quizzes are all spoken stuff, but they're written because I have to be quizzes. I have to have the computer grade them. But since I'm grading them, it'll be spoken. Okay? Are you okay? You're good otherwise?
Yes.